Hey folks, welcome back. In this video, I will be explaining about the AWS 3-tier VPC architecture using Terraform. Before you continue with this video, this is a GitHub profile in which I have implemented all the AWS VPC Terraform implementation code, and the link is in the description. Make sure you check it out. Okay, so before we implement Terraform, let's explain how the architecture looks like. So as you can see on the screen right now, we have a VPC architecture spanning across two availability zones. And in this particular VPC architecture, we have the main VPC component itself, public subnet, and two private subnets. And in the public subnet, we have a NAT gateway which has the elastic IP assigned by default, and then the public subnet and the NAT gateway is connected to the internet gateway. So this is the overview of the architecture. How are we about to implement this in Terraform? So basically there are two ways. One, by using the AWS individual resources. For example, we have the AWS VPC resource, and then we have the route tables, and then we have the security groups, and then we have the AWS VPC, and then we have the subnets. We can take individual resources, we can assign values to it, and then start implementing. Or there is another option known as VPC modules. So what is a module? In Terraform, module is nothing but a container of predefined resources of that particular cloud provider, which is written in Terraform scripts. So that is a basic definition of a module. So in this particular, for example, in this specific example in AWS VPC, we have already a predefined module which has close to 38.5 million downloads, which is pretty huge, by the way. And if we go to the complete VPC example, see, there are many examples within the VPC itself, like the IPv6 issues, network ACL, simple VPC, VPC flow logs, and so on. So there are many examples, but one of the most used example is the complete VPC. So if we go to the complete VPC, it looks something like this. Let me show you. Yeah, so in this complete VPC, it will give us a GitHub repository link. Okay, and if we go to this, so this is the link. So in this particular VPC module, they have already defined the main resources inside the main.tf, and then its respective output values, input variables, and then versions.tf. In every single Terraform module, it starts with a versions.tf, because in versions.tf is a file where we will be defining the Terraform block and then the providers block. Without these two, none of the code is going to work. First, we need to download the required version of Terraform, and then the required version of the provider along with this. So without these two, nothing is going to start. So these two are very, very critical, very vital as well. And after that, we will go to the main.tf. If we come back to this architecture, we have all these components, right? The public subnets and private subnets, NAT gateway, which is spanning across different availability zones. If you need, if we go with the individual resources, for example, it'll take a lot of code to implement the same infrastructure. Whereas if we go to the Terraform, they have already defined a structure to so that we can just import these particular arguments, and then just give in the values for these VPC component values. Yeah, so this is the example. So before starting off with the module, we need to import it. So as you can see over here, so once it is imported, then we need to give in the relevant options or relevant values to those VPC component. For example, the VPC name, the VPC CIDR block, and then the availability zones, private subnets, public subnets, database subnets, and so on. So if you look at my code right over here, so I have defined the versions.tf, where I have defined the Terraform version with 1.3, and then the provider as AWS region. And let's start off with the module. So in the module, I have imported the AWS module VPC, and then the module version. Okay. So right now I will be explaining the resource, which is the VPC architecture, and while explaining, I will be explaining its associated Terraform concepts, like the variables file, the input variables, the local variables, the outputs, .tfvar files, and so on. Okay. So yeah, so as you can see over here, the name is var.vpc-name. So where is the VPC-name? So if we go to generic variables, okay, one of the best practice is that we tend to variabilize the resources so that the entire Terraform module becomes reusable. Like for example, if you would like to deploy the same infrastructure with a different configuration values, so what we do is that since we already define a variables file, we just change the variables and run the Terraform commands again, so that depending upon the input variables, the same infrastructure gets deployed with the different values. So that is the main purpose, and this also improves the efficiency of the implementation. So that's one of the main reasons. So in the generic variables, as in these variables can be used across the module. It's not resource specific, right? So in the generic variables section, I have created the AWS region, which is US East 1, the business division as HR, and then the environment as dev, which is the development. I also like to mention one more thing related to the variables. There's something known as Terraform.tfvars. Since what Terraform.tfvars does is that it supersedes the generic input variables defined sections. Okay, so as you can see over here, we have the AWS region, business division, and the environment. The same are defined over here. If the Terraform, whatever the values are defined in Terraform.tfvars, that gets replaced over here. Similarly, we have also defined the VPC variables file. So this file is only specific for input variables related to the resource specific, which is the VPC. So for VPC related values, we have defined it over here, and correspondingly we have vpc.auto.tfvars. So whatever value is given over here, this supersedes the VPC variables. In case if this is empty, then these values are taken into the resource right over here. So I hope this is clear. Right, so next we have, so looking at the module, so we have the availability zones, we have the private subnets, public subnets, and database subnets. So we have imported the same thing over here. But what are these additional what are these additional fields? Database subnet, group, and database subnet route table. Okay, let's go to the first one. So as you can see over here, there are certain default values which are true and false. Okay, and depending upon this, we have to define. Okay, for example, if we want to create a route table, see, by the beauty about this VPC module is that the public and private subnet, if once those two are defined, by default the route tables are created, and once the NAT gateways are defined, the the route tables association happen by default. Okay, so that is one thing. And but for the database subnet specific, if you want to create a route table, then we need to define this particular value. And how is this value, and where is this value taken from? So it's taken from here, create database subnet route table. So we'll take that, and by default it is false, so we'll give it as true, and then we'll be defining the database subnets. And as you can see in the architecture, we need a NAT gateway. So likewise, we have also taken the NAT gateway. Enable NAT gateway is true. In production scenarios, this should not be true, which is single NAT gateway. In production scenarios, we will not have a single NAT gateway. We will have multiple NAT gateways across different availability zones. The reason I'm taking a single NAT gateway is because since it's only a learning purpose, I've taken only one just for the demonstration purpose, nothing else. And after that, we have enabled the DNS host names so that we can check check the public host, which is the jump server. So apart from that, I have also given the tags for the subnet specific, the VPC tags, and the resource specific tags. So this is the overview of the VPC implementation in the Terraform. Okay, so now let's implement it. Okay, so we have all the files. So the first command is going to be Terraform. So Terraform init. So what this command does is that it's going to download the version of Terraform which we have defined in the versions.tf file. Okay, so right over here, so it will be downloading the Terraform version 1.3. The latest version, which is like 1.37, 1.39, and so on. And then it also downloads the provider, which is the AWS Terraform provider version. I think it's still downloading. Okay. Yeah, so now it's downloaded. So then, and the next command is going to be Terraform validate. So what Terraform, my mistake. Terraform validate. So what the Terraform validate does is that it's going to validate the syntax of each file, of each Terraform files in the module. So it's still checking. Okay, now it is success. So now let's Terraform plan. Yes, so as you can see over here, it is going to create 22 resources in total across both the available availability zones. And then yeah, so let's see what it is about to implement. Okay, so now it's going to create the database subnet, then it's going to create an elastic IP for the NAT gateway, and then it's going to create the internet gateway, again NAT gateway for this public subnet, then the private subnet, sorry, the route table for the private subnet, and then the public internet gateway, and then the route table for the database subnets, and then the route table for the private subnets, and then the route table for the public subnets, and so on. And we also have the route table association. So as I mentioned before, the route tables are created and associated with the help of the modules. If we are defining it by Terraform resource, we have to do all these things manually. So depending upon the scenario, we will, in most cases, we will be going with the modules, else we will be going with the individual Terraform resources. If we have a different kind of architecture which doesn't suit the module implementations. Yeah, so as I was saying, if you want to define those, if you want to define these resources, we can use a Terraform module. If the module doesn't fit for that particular architecture, which we are about to implement, then we can go with the Terraform resource implementations. That will increase the code, but it's going to guarantee the implementation depending upon our code definition. So apart from that, all those things are defined, and I forgot to mention one more thing. So we have something known as output variables. Okay, so once the resources are defined, what are its values, what are its attributes, what are its arguments? For example, let's say that once a VPC is created, it has its own VPC ID. And the other example is that once an EC2 instance is created, it has its own public and private subnets. How to get those data? If we don't want to go to the AWS console and check, right? So for that, we have the output values. And as you can see over here, I have defined the output values for the VPC ID, VPC CIDR block, and then the availability zones, the public subnets, private subnets, database subnets, and then the NAT public IPs. So these are the outputs related to the VPC module, which I have defined. And these are the outputs which is about to be implemented once we perform Terraform apply auto approve. Okay, so right now, since the entire plan is in place for this particular infrastructure implementation, we have already given the apply action. So now the infrastructure is getting created. This is the entire this is one of the major life cycle process of infrastructure as a code. So right now, the entire VPC architecture right over here. Let me show you that again. So this architecture is getting implemented using this code right over here. So this will take a couple of minutes. I'm going to pause this video, and once it's complete, I'll resume it. Okay, so now the entire implementation is complete. It took around like 5 minutes. Okay, so now all the 22 resources are created, and we have the output values such as the subnet IDs, and then the public IPs, the private subnet IDs, public subnet IDs, and then the availability zones, and then the CIDR block. So now let's check with the resources, right? So we acquire, as per this architecture, we are supposed to have 2 public subnets, 2 private subnets, and 2 public subnets, 2 private subnets for EC2 instances, and 2 private subnets for database instances. So let's see. So we have one VPC which is created as VPC demo 1. Where is it? Name as the local variables. VPC demo 1. Yes. Okay, so that is created. So the VPC is created, and now we will go with, what's the second one? Let's check the public and subnet, private subnets. Yeah. So we have 1, 2, 3, 4. So we have 1 and 2 public subnets, and we have 1 and 2. So we have 2 private subnets and then 2 database subnets. So the subnets are created. So the public subnets, private subnets are created. So now let's check the NAT gateway. Yeah, so we have one NAT gateway as well. So one NAT gateway is created. And let's check the internet gateway as well. Let's check the internet gateway. Yes, so we have the internet gateway as well. And I would like to show you one more thing, the importance of terraform.tf file. So here, terraform.vpc-auto.tf, okay, everything is in place. Right, so nothing. Yeah, so this is the overall implementation of the AWS VPC 3-tier architecture, and the entire code which I just explained right over here, the entire code base of this 3-tier VPC architecture is in my GitHub repository, and I've linked the repository link in the description. Make sure you check it out. Clone the repository on your computer, try to implement it, make some changes, learn something, make some changes, and that's how you learn by doing. So all the best. Make sure you check out my next video about the EC2 instance implementation. Let me give you a small overview about it. So with the same VPC architecture, what I'll be doing is that along with the VPC module, I'll be introducing two more modules. One for the security group creations in the both public subnet and the private subnet, and then I'll be using the EC2 module for creating one bastion host EC2 instance, and then two private EC2 instance in the private subnets. So that will be for the next video. Until then, take care. Cheers.